Good afternoon. We're actually going to be talking about congruent shapes today, which is part of investigation 2. You can see in this picture, and if you want to look at it more closely, it's in your book on page 369, that roof trusses, this is a roof truss, are made in many different shapes. This is actually called a W truss, and you can see why, because it's got this nice W here. But it's built with triangles within triangles. And we talked about already how triangles are the most rigid shape or strongest shape, so that's why they're actually used here in the design of the roof of a house. So here they actually have several trusses in a row, and then what they do is they actually stick plywood on top of that, and that's where they put your, whatever shingles you have or whatever surface you have on your roof. They stick that on top of that. So what makes your house strong is that it's built from several congruent triangles. If they weren't congruent triangles, then you would obviously have some issues with your roof. You might even have issues with the framing of your house as it settles over time. So the location of the trusses and the design of them is very important. We want them to be rigid and really, really strong. So to do that, it's really important that they are identical or congruent. So congruent meaning exactly the same shape and exactly the same size. So that would require a lot from someone who's doing construction or someone who's building these trusses maybe in a factory somewhere to be shipped out to a middle town to be put maybe in a neighborhood in Parkside, for example. So they would want to make sure that they're all perfectly the same. And so to do that, we want to know how many measurements we might have to take. We might not have to take every single measurement of every single angle and every single side length. So that's why we're going to be talking about triangle congruence properties, to see if maybe we can take a minimum number of measurements and use that to know still definitively that the triangles are congruent. So you can see here that there's a truss. This is actually a local truss. I'm not sure if this looks familiar, but this is in Appos Field House. See, right here. Sometimes they're exposed on the interior of your house when you look up, and sometimes you can't see them, but they're still there. There they all are. And then you can see that triangles, like we talked about before, they're the most rigid shape, so they're used in building some of our, famous different architectural models, and sometimes they're just used in general construction. So there's that. So really our essential question is, what combination of side or angle measures is sufficient, so is enough basically, to determine if two trusses or triangular shapes are congruent. And then we're going to basically be learning about how we can decide if two triangles are congruent. And sometimes you have enough information. So let's say I measured this side length, and it ended up being the same as this side length, so I know those two are the same. And maybe I also know that these are the same length because I measure them. And then I measure this angle right here and this angle right here. That may or may not be enough information. I might have to gather more information. I might actually have to measure this side length also. And if those are also the same, I can say, yes, these triangles are congruent. But maybe if I don't measure these, then I don't have enough information. Actually, it could be two different triangles without me knowing. So that's what our lesson is about today. It's about triangle congruence properties and trying to figure out when do we have enough information to prove that two triangles are the same. So what you're going to do is you're going to watch video 2 right after this.